A couple things. The first one, this is not a real technical presentation. We're not going to talk about C groups. We're not going to talk about namespaces. We're not going to talk about IPVS or HTTP resource routing meshes. This presentation, I was asked by the Docker folks to put something together to talk about kind of real world use cases, folks that are having a hard time adopting Docker in the enterprise, and some of the things that as a company, which I'll talk a little bit about, that we've done with our customers in ways that are frictionless and easier to handle objections with adopting containers in enterprise customers. So I'm going to tell you a quick little short story, kind of my little bit of history, give you some perspective of where I come from and how this works and maps into an enterprise adoption story. And then we're going to talk about the 3 use cases. Briefly, if you don't know what what shift left is, or if you're not familiar with Jenkins, if you're an operations guy, you can, let's actually show of hands. Who's more ops focused? Okay, and Dev? And okay, cool. And if you didn't raise a hand, then I'm assuming you're in business, you own a company or something like that. So if you don't know what some of these things are, feel free to look it up as we kind of kick things off. So let's jump in. So I think containers, and we heard this morning, like thinking fast, helping customers solve problems and adapt and become more competitive. For me, this epiphany moment happened quite some time ago. When you talk about software development lifecycle and operationalizing applications, these things are not new challenges. They've been happening for quite some time, and different technologies have kind of come up throughout the last, for my 20-year career, that help promote transformation and change. So. One of the things that for me, when this really kind of as a consultant, the first time that this was something that I kind of grabbed onto was back in 2005. So in 2005, Sun introduced Solaris Zones, and I was working for one of the 2 largest telcos in the U.S. That had a very large Sun footprint. But we're very adverse to taking on new technology. Things like, our existing teams don't know how to use the tech. Our vendors don't support the technology. In this case, they had a lot of network equipment providers that had very specific requirements for their applications that were being deployed inside their data centers. And things like it's too new, right? This is just something that until is better proved, we're not going to be the first ones to adopt the technology. But as a consultant and leading a team of folks that were tasked with solving real world problems, data center sprawl, not having enough power in the data centers at the time, and more infrastructure related, we knew that the right way was to use zones as a technology. So we knew that the other things besides the sprawl, there was consistency across deployments for some of the issues that we were running into. When there was a tech refresh that needed to happen, how do we make that easy? And as hardware was being commoditized, we wanted to be able to rapidly shift applications around and take advantage of those cost efficiencies. So we set forth on starting to use the technology. I don't want to say kind of under behind the scenes without the customer knowing, but some apps were being deployed on Solaris 10, right? So in Solaris 10, everything is deployed. If you're running an application back then, is deployed in a global zone. So every single application was already in a zone. So you were using it by default. There were other applications that we were bringing to the table to manage the environments that were our own IP. And we deployed those in zones and managed them ourselves. So these weren't network equipment provider apps, they were our own applications. So by doing that, we started to show the customer that these weren't technologies that weren't something you can't use. It wasn't something that you needed to be afraid of, or it didn't even fit into your operational models. It actually did quite well. And that started spreading throughout the entire organization, ultimately culminating with the next big release of technology, which was ZFS. The customer picked that up and started running with it more quickly. So it's kind of this transformative journey that the technology enables. And Ben was saying it this morning. I think containers are kind of in that same point where you can start to catalyze some change in environments more quickly. So the question is, how do you adopt the containers if you're not already using them in the enterprise? How do you handle the objections? What are some of the things that you can do to promote container use and Docker use inside your own environments? So I don't know if you guys, anybody knows who this guy is. We had the 35 and under test, Bob Ross. The thing that you need to think about in this whole process and what we as a company do is help folks think creatively. So the use cases are certainly things that you can use and you can lift and run with, but think about things in your own processes and your own your own stories and teams that you can start to creatively use the containers. So just a quick note on me. So I call myself a semi-recovered Unix engineer. I'm still, even though I'm the CEO and co-founder at Nebulaworks, I still do a lot of hands-on work. As a Docker captain, I'm out evangelizing and talking about the technology, but to get to that position or be offered that title, I had to do a lot of work with Docker. We started building platforms. The first production platform using Docker that we put in place was in 2015. Using CS Engine 1.6. So if you guys have deployed things all the way back to there, you understand the trials and tribulations that you need to go through in order to build a platform to run containers at scale using open source tools with auto registration, auto discovery, and everything else that real enterprise platforms need. So that kind of gives me a little bit of history, and for the last 3 years, we've been doing that at Nebulaworks with our customers. So besides the training materials that the Docker folks have put together, up-leveling teams, putting these processes and process in place to actually use a CAS, use a container platform, build the pipelines to automatically get a high amount of code coverage, which we'll talk about the Jenkins piece in a minute, all the way through automated deployment for sophisticated customers. So as we do the use cases, if you have questions, raise your hand. Love to make it more interactive than me just talking. It's nice to have a smaller group. We can do that. So use case number 1, lift and shift. Who's familiar with shift left? Sorry, shift left. Okay, cool. All right. So as we move through this, and talk about rapid prototyping, but as Visa said this morning, you have a developer that comes on board, you want to start committing code on day 1. It's not just committing code that's idle, let's commit code that actually goes into production as quickly as we can. And in order to do that, all of the development processes, the test processes, and the deployment processes need to shift earlier into the cycles of all of those discrete things that we need to accomplish in order to launch applications and put them into production or put code into production. So use case number 1 is, how do we start doing that at the developer, right? How do we increase the velocity, taking what we have today, which is kind of the model. We'll talk about what most organizations we run into are doing today, and then how do you leverage Docker and avoid constraints. So the old way. So you go and you get a Linux VM, or potentially you get one given to you by your IT shop. From there, you install a bunch of prerequisites. It's the standard issue. There's a Python application, and we need to install pip, and we need to install JSON, RPC base, and then from there, because we have to pass everything through IT, we submit a ticket to ServiceNow. Right? So the ticket goes into the queue, and eventually, at some point, based on how many outages there are, or if there's a fire drill, or people are on vacation, depending on how big the company is, a VM gets minted with your prerequisites in it, and it gets stashed into VMware as an image, or it gets put into to OpenStack as an image in Glance, and that's great. Okay, cool, it's there. And then they provide it back to you. And that's your own specific image. It works great for the things that you're trying to do. So clearly, the question is if what I provided in that initial build, and it's in a mop or in that ticket in a text file or an email, is it actually being prepared the way that I need it prepared in order to do my own development, right? So this takes time, and we're not shifting to the left and becoming more rapid, we're shifting to the right and taking more time and involving more teams. So that's fueling the shadow IT move, right? Developers can swipe a credit card, go to Amazon, do everything that they need at their own pace. So how can we potentially change that paradigm without changing the need to get IT involved, right? So one piece that we want to remain constant, because an objection is that IT needs to be involved with the process of potentially creating an image or creating an instance, right? So instead of putting an email together, we build a Docker file, right? So we know that everything in this Docker file is written by the developer. It's the way that they want to instantiate the environment that they're going to be doing their development in. It's something that we can then take and do this on our laptop, or if we have a VM that's just running a Docker engine that's provided by IT, we can do the same, run the same set of commands, build those Docker files there, and then we push that into a shared resource like GitHub or GitLab. At this point, we can open a ticket and say, go pull my Docker file, right? So instead of pulling my email, instead of pulling a Word document, instead of pulling a mop, right, if you've worked at the telcos, you can just pull the Docker file. Now, this doesn't necessarily have to go this direction. I mean, a lot of times this is automated, but in the enterprise, there's a gate, right? And the gate is IT. So now IT can take that, build an image, stash the image instead of in a VM, put it into a registry, like Docker Trusted Registry, and we know that every time that image is created from the Docker file, if we're creating a new image, that it's exactly the way that it was meant to be created by the developer, right? So we use the word idempotent, right? So no matter how many times we create it, if the registry goes away, if another developer wants to take the Docker file as a base and do their own work, or they want to use the image as a base, it's the same every time if we're building from file. So again, one of the questions that's asked, or one of the things that we're held back by is, well, IT says, well, I want to be involved in the process, right? The objection, how do you handle, I want somebody to see these things. This is where we can have if a developer is creating images, instead of pushing things to a distributed source code management like GitHub, you can have one registry that takes an image that developers are building, and then another registry that's been set up by IT that potentially goes through the Docker files and makes sure that those images we can have them scanned like we saw this morning, or we can build separate images that get placed into a trusted registry for special purposes that IT is blessing. So keeping them involved, keeping the ability for the IT folks to have a window into what's going on inside of the environment. Any questions on that? None? Cool. This one I find a little more interesting, right? So the shift left is certainly something that we see folks doing, especially newer companies. But how many people are using Jenkins? All right. How many people are statically creating Jenkins agents? Wow. Everybody's doing this elastically already. Okay, that's good. So static Jenkins environments are super boring. Most of our customers that are running Jenkins, especially inside of public cloud providers, there's a lot of waste. And as more code coverage and test coverage goes for developing applications, how do you handle the scalability of the app? So the old way is we deploy a master or a set of masters in VMs, and we deploy a handful of Jenkins agents, and each one of these agents is specific to the environment that you're building, right? So you may have a Jenkins agent that's doing Java builds and Maven builds. You may have an agent that you're specifically saying, I want to send Go builds to. I mean, depending on the environment, you can have many, many, many different workloads. And each one of those Jenkins agents is specifically customized, like I said, to handle those builds. That's great. But what happens when those agents are overloaded, when you need to scale? So now we got to go through the process of potentially going to IT, getting another VM, minting an agent, the VM, putting the VM into production, putting the agent into Jenkins, and so on and so forth. So the build and release engineers have they got to keep up. I mean, and then how many of these things do you actually create based on load, right? And then once you create them, then we get this issue of, okay, now our jobs aren't running anymore. Our agents are sitting here statically running, and the meter is running, and we're being built, right? And depending on the Jenkins environments, those could be big VMs. So how can we, in a low friction way, start to introduce containers into the Jenkins environments, right? But the reality is, like I said, this is super boring and it's not exciting. So we'll throw some vents on it. We'll make our Jenkins life exciting. So here's what we can do now, right? So Jenkins master stays the same. Don't touch it. It's still running on a VM. If you want to run it in a container, that's totally cool. It comes with potentially its own set of issues, especially if you're doing other builds besides Linux builds, like Xcode builds or Windows builds, dealing with port translations and things like that. But at any rate, so you run Jenkins as a VM, and instead of provisioning just bare metal machines or VMs to run the Jenkins agents, you set up the Docker Cloud plugin, and not Docker Cloud meaning Docker going to Tudum, what was once Tudum and is now Docker Cloud, but a set of machines that ends with a Docker API. So we can create images that are unique for each one of these builds now. So we can now start taking advantage of the process of using a Docker file to create an image, add in the things that we need for the builds that Jenkins is going to be running, and then as jobs come along, we can tag those jobs with specific tags that actually will launch the agent, the Docker container, and no matter, depending on how many jobs we have, we can elastically scale those Jenkins agents. And when the job is finished running, they can go away, right? So we don't continue to sit and run them. Now, granted, you still have to have a underlying infrastructure. It's not like you're going to have, if you're going to run a number of containers, you need machines to run them on. But the beauty is, and the frictionless part, which helps kind of bring container utilization into the enterprise, is you don't have to touch the other agents that are already there. So in the event that there's builds that aren't necessarily critical for the company and you want to start using a new technology to save some money or to be able to scale as you hire developers as the pace of development growth goes, or you want to provide environments for contractors to work in, they don't have to go on the agents that are statically provisioned. You can start to use another infrastructure. And we've had actually, this is the #1 use case as a company that we've ran into in the first year and a half of using Docker and helping our customers, is getting Jenkins into an environment that scales. And not only that, is we can migrate between cloud providers on-premise and off. So by using Docker now, it's completely portable, and we don't run into any issues of lock-in with an infrastructure provider. Cool. Okay. Questions? None? Save it to the end? All right. Okay. And the last one, which is rapid prototyping is kind of had a bad rap. But I think now with kind of the 3D printing and just-in-time being a business driver, rapid prototyping is losing the tarnish that it had, and it's now something that is being used more, especially within our organizations, customers that we're working with that want to quickly develop something and see if it meets the product team and the business demands that they have. And we used to call it a rapid prototype, call it an MVP, call it a riskiest assumption test. The reality is that these things have to happen more quickly than they've ever happened before. And there's been some technologies, and we'll talk a bit about this in the use case, that have helped kind of get there. But they were more, they required more boundaries in order to use them. And what we want to do is move those boundaries and not have a tightly constrained tool that developers have to use in order to move forward with their prototyping. So let's look at what we used to do before. And before actually is actually pretty modern. And I'm going to ask you guys another question for a show of hands here in a second. So product team has an idea, and they're like, hey, we've got this great, this concept that we want to test. We want to start to do develop some visualization dashboards for some of the data lakes that we have for some analytics work. Okay, cool. So quite a few companies have invested in who's using PaaS. Wow, not one hand. So no platform as a service in any of your guys. Okay, well, cool. Now you just can jump right from using PaaS, because I'm gonna talk a little bit about why it slows things down. So the first thing you do in a PaaS, if you're not familiar with how they work, or if you don't use Heroku, if you don't use things like Beanstalk, is if you have an application and the build pack that you're trying to, the application you're trying to develop, the framework you're using, doesn't have a mechanism to inspect the code and determine what type of application it is, it's a build pack, and then be able to build the application, you have to ask the question, is the build pack available, right? If the build pack isn't available, guess what we have to do? If it's not you that manage the platform, and you don't manage creating the build packs and putting the build packs into the PaaS, you've got to go to IT, all right? So before you even start, you've got to get somebody else involved, right? To create a ticket and let the IT team work on that in the queue that they have. The second thing that you need, if you're developing applications that are not just your piece and you want to do any type of integration between the different components, you've got to find out if there's a service that's brokered into the PaaS. So if that data service isn't brokered into the platform as a service, and you can't call it, you do the same thing, right? So now we turn around, we submit another ticket to IT. And I'm not talking bad about IT. It's just this is the process, right? I mean, they are involved, and it's the way that things are controlled. So once that's done, we push the build packs and the services that are brokered into Cloud Foundry, PCF, OpenShift, or Heroku, and we provide that back to the developer. The developer creates the MVP or the RAT, provides that package in a nice format to product, and the product team says, yeah, that's great. It took you 3 weeks to put something together. We've already moved on, and we're doing something completely different. And we don't want to do that. So start over again. And the way that we're building applications now, and polyglot applications, there's more and more frameworks every day. And moving from just using Java and having a build pack for Java, this becomes a problem, right? Especially when we start scaling. So what can we do to modernize that process, right? Let's use containers and make it a little bit easier to consume. So product has an idea, they come to the developer. Developer says, okay, cool, this is something I can get. Rather than having to go to get a service that's brokered in, as long as we have a sanitized copy of the data that say we want to use, and we have a framework that has a container that's already developed, or a container image, sorry, that's already developed, we can choose those. And we can go from the public Docker Hub, right, and images that somebody has made that fit the need exactly to what you're looking for. If it's an official image, something that's certified that you want to start your development on, you can go to the Docker store to get it, or you can go to the registries that are on your team, on the registries that you have behind your firewall, or public registries that they probably shouldn't be, and pull that code. But keeping in mind that we're talking about build pack issues and those images not being created, we'll go pull the public ones. So once we do that, now we can start to stitch together the application. And if we kind of go back to the shift left concept that we first talked about, is we can start doing that development right on the laptop, right? And we don't have to worry about going and having anything else created in order to start doing the development efforts that are required to put together the MVP. From there, because we've already developed the application, we can take that, push the set of applications plus any files, manifests that stand up the applications. We can send them over to product, and if they bless it, great. If not, then you can move on. But we didn't spend a lot of time in what people refer to as the ideation phase, right? And actually putting something together. So 2 questions usually come up, which is, okay, well, this is great. I mean, I've got a PaaS if you had one. A lot of them will run containers. So the question is, why wouldn't I just use the PaaS? And the answer is, well, besides the build pack issue, there's certain things that you can't do inside of containers, inside of a PaaS. So for the developers, that's a little less of an issue. But let's say you're an operations folks and you want to start using new technologies and want to see something like Prometheus run. How do you quickly put that in place? So this is a product team. It may just be an operations team that says, hey, we want to start monitoring things or collecting telemetry in a different fashion. How do we do that? It's a lot easier to do it inside of a container than brokering and trying to run those containers on the platform. And then for really cutting edge companies, like companies that are getting into programmable silicon like Barefoot Networks, you can actually start to run inside of containers environments that look like the silicon that eventually will go to tape and products are made out of, right? So this is now taking the concept of rapid prototyping to a whole nother level, right? You're not getting into the point where you're talking about really long product cycles. We're now testing our riskiest assumptions on the fly. Any questions there? Cool. All right. So I said it's not super technical. That takes us to greatest of all time, right? So if you're trying to solve some of these problems, some of the things in your behind your 4 walls with your teams, ways that you can take and start to adopt Docker containers, clearly there's many more things that you can do with them. Like I said, these are just some of the handful of ways that we've been interacting with customers and helping them through the adoption process in the last 3 years. I'd be happy to talk to you more about them. But in summary, kind of the things that we see, as you go through the process of enterprise adoption, don't be intimidated by the technology, and certainly don't have teammates that have never seen it be intimidated. So the first thing to do is to think small. So don't try to bite off huge projects that have a much higher chance of failure. You want to start with the smallest units of change that's possible. Using Docker for Mac, using Docker for Windows, setting up lunch and learns, or talking about things within your company to kind of have a common vocabulary, and then working on small chunks is a way to start building consensus and getting teams to work together quickly. The second thing is, which I don't have a bullet, but expand and extend the socialization capabilities that are part of the Docker image creation process and container use. That's what doomed Solaris Zones, right? So the technology of Solaris Zones were great, but the fact is we couldn't really move applications around freely and share them in a well-defined way. We had flars, yeah, that was great, but that's like moving golden images of VMs around. A Docker file is something that's completely different. So if you use Docker files and start to socialize the code that you're committing and get that shared amongst team members, it goes a long way towards container adoption. The initiatives that are constrained by gating processes. So if you look across what you're responsible for and the teams that you work with, where are the gates? And if there are small gates that can be overcome by using containers, that's usually a good place to kind of insert the use, right? So in the use cases I was talking about, the gating factors are, we don't have enough VMs and there's server infrastructure that needs to be acquired in order to run Jenkins agents. You can shoot your Jenkins agent, if you'd like, to a public cloud provider and run that right away, right? So there's a gate and a way to overcome it. And the last one is, and this is probably the most important thing, we tend to focus on the things that we read about and hear about that are easiest problems to solve because it's just the nature of, like I was just saying, think small and the easy things first. But understanding that the pipelines and the process is more important than the deployment and the end target and the endpoint that you're trying to deploy. So instead of spending a lot of time trying to figure out if DDC or Swarm, Kubernetes or Mesos and Marathon are the proper place to spend your time, what is the technology that we should be using to deploy a container, figure out the process for to determine the best way to take your application code and then test it and then deliver it as an artifact and then figure out the deployment endpoint. Because the odds are the deployment endpoint is going to change either by nature of what you're developing or it's going to change over time. So you want to remove and abstract the pipeline that's doing the delivery, the build, test, and delivery away from the continuous deployment piece. And we've got a lot of customers that tend to focus on just the deployment piece when they haven't fixed the 80% that's actually taking the code to production. We have one large financial services customer. They spend 70% of their budget on development and delivery of code, not on operationalizing the code. So, when you start talking about the numbers, being able to move the needle, fix the process, and you save a heck of a lot more money as an organization. So with that, wanted to say thank you and return a few more minutes of extra time to your schedule today. If you have questions about any of this and don't want to raise them right now, that's my Twitter handle and the company's Twitter handle, and you can find us at Nebulaworks. But I'd love to take questions. We got some time.
Thank you very much, Chris, for that talk. Please, all the attendees, before I forget, if you find this an exciting talk, don't forget to upvote it in your app, in your DockerCom app. And now we have questions. If you have questions, I ask you please to come here and queue here so that you can take my mic and we can hear your questions in the video.
I just have a question about your Jenkins use case.
Yes.
With the multi-stage builds now within the Docker file, would that change that paradigm completely, right? You wouldn't even use agents anymore?
It depends, right? So the first question that we ask is, and it's a good question, right? Because as specifically related to Docker, as the technology becomes more advanced, the functionality like multi-stage builds does come into play. In Jenkins, we find that most customers want to look at a way to use the technology consistently across every build pipeline that they have. Most of our customers don't have only builds that can be used in are going to be taking advantage of containers themselves. So we're not minting a container that's going to be deployed. So for example, we have customers that are using Docker containers to build Android applications that are eventually deployed into the Google Store. As we go build the code and test the code that's being run in a container image, a Jenkins agent, we are using pipelines, not the technology that's associated with multi-stage build. So we're not taking, in that process, we're not doing a build and then creating an image and then specifically calling out the things that we're going to be pulling and dropping into an artifact that's going to be published, right? So there's the piece that's about how you write your pipelines and what technology you're using to write your pipelines, and then the technology you're using to create the image. And in some cases, you may use a technology like Packer instead of using the Docker build process itself. So does that answer your question? Okay.
More questions? Okay, thank you once again, Chris, for this talk, and give him a warm hand.